To get these little buggers to work, I'm gonna need some more power. This strip of LEDs, RGB LEDs, meaning each LED actually consists of 3 LEDs, a red one, a green one, and a blue one. And different signals sent to each one of these LEDs will turn on different amounts of current or brightness for each one of those colors. Now, these LEDs, this particular strip is referred to as a WS2812 LED strip. Now, a 2812 LED strip, as I said, each LED requires, well, they've got 3 LEDs. So you've got a red, a green, and a blue. But each one of them requires, if it's fully on, 20 milliamps. Well, that means per individual RGB LED, in other words, just one of the lights, that means since we have 3 LEDs, a red one, a green one, and a blue one, then each one of those lights, so each one of these individual lights here requires a total of 60 milliamps. Well, this full string, and this is a pretty short string, this full string has 30 LEDs. So you've got 30 times 3 times 20 milliamps, which means that's 1.8 amps. Now, I have this guy controlled with a little Raspberry Pi. I'm not going to hold it up. Well, I probably could hold it up, but it's kind of tied up with a whole bunch of wires here. Because, well, this is a prototype circuit. And this prototype circuit is, whenever you build a prototype, things tend not to be production quality yet. So anyway, this little Raspberry Pi, it requires some current of its own. And so whenever it's being driven, it's got a USB connection that delivers, well, on a good day, 3 amps. Now, completely disconnected from everything. No keyboard, no Ethernet, no Wi-Fi, no USB connections, no HDMI monitor, no mouse, nothing. It's still going to require about 600 milliamps, 0.6 amps. So, from this 3 amps, bare bones, we're already pulling away about 0.6 amps, or over 0.6 amps, which means that we're left with, well, after a while, plug-in monitors and keyboards and so forth, you've chewed into the current that you're asking to draw for those LEDs. And what if I want a longer string, something that's got more LEDs than just 30? If you've got perhaps, a 9-foot long string with 90 LEDs, suddenly we're looking at almost 6 amps just for the LEDs, way outpacing what's available from the USB. Now, for production quality things, yes, there are power supplies out there that you can get. But it'd be really nice if I could have a power supply that I could use on my bench top in order to access more power. Let's take a look real quick before we do, though, at the connections coming off the Raspberry Pi. And this is true for a lot of these devices, but I want to specifically talk a little bit about the Raspberry Pi. On the upper, or on one corner of the Raspberry Pi, we have got a 40-pin connector. I probably got 38 pins there, but that's not important. Let's take a look at what some of these pins do, what some of these pins are connected to. Now, these top 2 pins right here, top 2 on the outside edge, these guys are 5 volts DC. In other words, that's the power that we could use to drive those LEDs. That actually comes directly from the power supply, directly from the USB power supply. So, because the Raspberry Pi actually does not use 5 volts. Instead, it uses the voltage that's connected to that pin right there, which is a positive 3.3 volts DC. All right, not enough voltage to run these LEDs. Now, That 5 volts right there, in fact, if we were going to use the voltage coming from the USB power supply in order to control the in order to control these LEDs, we would probably just drive it directly off of those guys. Those guys are fused, but really not much else. It's just, there's not any control, it's just coming directly from the USB port. So, what we want to do is replace the 5 volts that would be coming off of this guy in terms of the USB and replace it with what we call a bench top power supply. Or a bench, help if I spelled correctly, wouldn't it? A bench power supply. In other words, the power supply you're going to use on your workbench, right? Well, let me clear this up a little bit and we'll talk about how we can make one out of spare parts. Now, Amazon is quick, but it's not quick enough. I wanted to get this thing up and running this afternoon, and I don't have time to wait around for a power supply to come from the web. No, so I want to make my own. Now, what I did have was, well, a couple of things. First of all, I had an old computer that I used to have in my truck, and it has this old style ATX power supply. Now this one is specifically set up for very small computers. Things that are about the size of, oh, I don't know, a very small pizza, all right? And this one is actually an old style ATX power supply. And when I say ATX power supply, what I mean is a power supply that is meant to drive a computer and all the components in the computer. Now the things that the computer needs, the voltages that a computer needs are, well, 5 volts DC, all right? It needs 3.3 volts DC. It needs, well, sometimes you've got motors and so forth that require a positive 12 volts DC, and even some devices in the old days, whenever we had things like RS-232 drivers that required just the direct voltage, you actually needed negative 12 volts DC. All of these power supplies, all these voltage levels are actually available from an old PC power supply. And at 0 volts, you have ground. Now, there are a couple of things that we could do to generate the voltage that we need. For example, from ground to one of the 5 volt DC pins, got 5 volts. Guess what? That'll drive our LEDs. From ground to 3.3, you got 3.3 volts. From ground to 12, positive 12, you've got the positive 12 volts. But you could also use this negative 12 as a lower reference. So you could have negative 12 and connected to the 5, that's 17 volts. Or to the 3.3 volts, that would be 15.3 volts. Or to the 12 volts, you could have a 24 volt potential to drive stuff. So these ATX power supplies offer us a lot of things. Now, this old power supply I have, plus I also had a mini tower that had not quite as small a power supply as the one that came out of this little pizza box that I had in my truck, but it also has the ATX connectors right here. Now this guy will provide more wattage and give you a higher current draw if you need it for your benchtop. So if we have access through one of these PC power supplies to all these different voltages, how are we going to actually connect to them? Well, what you might see is, well, let's look at this guy. I've got this is the one that was driving those LEDs. I've got this old PC power supply. This is the one that I thought, well, why wait for Amazon? Let's just make one. All I did was I took some double stick tape, stuck something called a header. So I've got this, or a terminal strip. So I've got this terminal strip here that has 2 screws that are physically connected. So I can screw one side in, a wire into one side, and then screw it into the other side, and that will connect physically those 2 wires. And so it was just a row of about 8 connectors, and I used those 8 connectors to access the different components in this power supply. So what I did was, from the back side of this connector, we're going to talk about this ATX, this one is a version 2 connector. All I did was I snipped the wires that I needed from here, and I simply wired them up to one side of this terminal strip. And then to the other side of the terminal strip, I wired up the voltages that I needed. So for example, I've got ground, that's this bottom one. Notice the black wire is going to it. That was the ground, the 0 volts for my LED string. And then I've got 3.3 volts. This is an orange wire, something you need to remember. And then we've got a red wire, that's the 5 volts. And then I've got 12 volts coming from this white wire. And then I've got negative 12 volts going to this blue wire. Then I have some other connections. So before we know how to connect up our power supply, let's figure out exactly where to get a hold of these pins. Now, this ATX power supply, there are two versions. There's version 1.0, which is a 20-pin connector. So we've got, let's see if I can do this right. Let's see. There we go. That should be 20 pins, right? Now, understand that the way the engineers number these pins, it differs slightly, not from ATX connector to ATX connector, but for example, the Raspberry Pi, its header is numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on down through the 40 pins. That's not the way these ATX connectors are numbered. This pin right here is referred to as number 1, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we number this column, from 1 to 10. Then we come back up to the top. This guy's 11, and this guy's 20. That differs from the way some ICs, some circuits some of these chips that go into circuits are numbered. A lot of those are numbered 1 down to the bottom on one side of the chip, and then you go across the chip and number up. So it's actually numbered almost in a U pattern. So 1 to 10, 11, up to 20 would be the way that most of these ICs are numbered. But that's not the way that these ATX power supplies are being numbered. So let's see if we can't figure out for this version 1 exactly what the purpose of each one of these pins is going to be. Now we start up at on the top, and these 3 pins right here, all 3 of these go to 3.3 volts DC. Now understand that for some connectors, this is not the only place you're going to find the 3.3 volts. For version 1, those 3 wires are the only place you're going to find them. But in order to make it so we can provide a lot of current, we give it a lot of wires for that current to flow through. This pin right here is going to be, and by the way, remember this guy, these 3.3 are orange, all right? Across the way, in this corner right here, this is negative 12 volts DC. This guy is one of the blue wires, all right? Now, remember, we have to have that reference, that 0 volts, in order to give us a reference to each one of these positive voltages. That is often referred to as a common. I'm going to write down here ground, but sometimes you also might see it as COM for common. This is going to be black wires, all right? Now, next, below that, we've got a red wire here. This guy is going to be 5 volts DC. And across the way, we're going to have this interesting wire. It's actually going to be green, and it's for PS on. Okay, that's a control wire, and we're actually going to have to access this wire in order to control our power supply. Now, what number is that? Well, this one is 11, so we have 12, 13, 14. So pin 14 is where this PS on is going to be. Now, PS on, if you've followed any of my other lectures, you've probably seen one or two of my lectures where we're talking about something being an active low signal. PS on is an active low signal, which means that if it's a high, if it's a logic 1, we're going to leave the power supply off. As soon as it goes to a logic 0, what we're going to do is turn on the power supply. So it's an active low signal. It goes active when we have a 0. These, let's see if I can do this. So we have a group of 5 pins kind of in a little U shape here. These guys are also ground or a common. They are also going to be black. Now, once again, the more current we need to flow, the more wires we need it to flow in. So there's a lot of commons here to give us an opportunity for a lot of those electrons to be supplied out to the devices. The pin here that was circled, or was surrounded by these commons. This is also a 5-volt DC. So these two 5-volt DC pins, these guys are going to be red wires. Now we have six more connections to do. This pin right here is something that we call power OK. It is a signal also, giving us more, giving us a better ability to see what's going on with the power supply. We also have, let's see, we have some of the older power supplies sometimes had negative 5 volts DC here, but the power supplies I'm working with have no connection at that particular pin. And then we have two more pins down here, pins 19 and 20. These guys are plus 5 volts DC, so these guys should also be red. Then this pin right here, this guy is a special 5-volt pin. It's a 5-volt SB for 5-volt standby voltage. And then we also have another plus 12-volt DC connection there. The plus 12-volt DC connections are going to be white. All right, so there are all of our connections. All right, now the version 2 is exactly the same for the top 20 pins. In fact, if you look at this guy, this is the little power supply that I took out of that pickup, out of my truck. And it only has a 20-pin connector, so it's got the old version 1. And the other thing that's interesting, and you probably ought to take a look at this if you're looking at one of these power supplies right now, the connectors. Some of the connectors are perfect squares. So some of these are squares, so that a plug that fits into it can be just a full square. But some of them have these beveled corners. So one of them is like this pin right here. It's got these fills in here so that only a pin that has those, only a connector that has those edges kind of filed off, filleted, is going to fit in there. So I can't accidentally plug this in backwards, because this pin right here, it has these little beveled corners like that. Instead of on the outside, if you tried to plug it in this way, these corners right here would be blocked from inserting into the connector by those fillets right there. So it's set up so that you can only plug the plug in one way. Well, the interesting thing about version 2.0 is that its pattern of keys, in order to make it so that the plug only plugs in one way, matches the 20-pin. So if I have a 20-pin connector, and I've got something on this guy right here, if I have a 20-pin connector, which is this guy, this is a 20-pin connector, but this is the 24-pin socket, I can't plug this in this way, I can't plug it in this way, I can't plug it in this way, but what I can do is, if you're looking at it this way, the plug actually matches, this 20-pin plug matches the 24-pin plug by leaving the 4 pins uncovered that are added to the bottom of the 20-pin version to make the 2.0 version. All right, so that will plug in just fine like that. So what do we have as new pins? Well, for version 2.0, it's exactly the same on the top 20 pins. The difference is we've added 4 new pins. Now, we haven't really added any new voltage levels or anything. We still just have the same voltage levels. In fact, this is 3.3 volts DC, right? This is another ground, all right? This guy right here is another plus 12 volts DC, and this guy right here is another plus 5 volts DC, all right? So really, all we've done when we went to version 2 is give more paths for 5 volts, 3.3 volts, and 12 volts to flow, and another ground for the current to be returned at. All right. So, how do we take advantage of this connector in order to make a benchtop power supply? Well, the first thing we need to do is make an on-off switch. Now, as I said before, this PS on, this is the connection we're going to need to make. This guy is an active low. And if you see on my power supply right here, what I've got is soldered onto this is just a switch. And I've actually soldered on and put some shrink wrap here so that it doesn't allow you to kind of accidentally touch the conductors. But all you do is you make it so that when the switch is in the off position, these two wires are disconnected. When the switch is in the on position, these two wires are connected. Now, if you know anything at all about an active low circuit, what we're typically doing is internal to the device, we have 5 volts DC going through a resistor, going to a switch to ground. And this position right here is what the processor inside of the power supply is watching. This is our PS on active low. So that means when the switch is open, this 5 volt DC is being pulled up to make it so that this PS on is a high value of 5 volts. When you close this switch, it shorts PS on to 0 volts, which makes this 0, which turns on the power supply. Now, if you're thinking about this, you think, well, where am I going to get the 5 volts DC if my power supply is off? Turns out there's a 5 volts DC that is always available. If this power supply is plugged in, if I've got, doesn't matter whether the switch is on or off, if I've got this power supply plugged in, there is an internal 5 volts that is always available. That is this 5 volt standby. So if you look at this connector, we actually have access. If this guy, if you were to take a voltmeter and look at these pins, you would see that this pin right here, this pin 9, is a high voltage, is 5 volts. And that is what's running this, so that whenever you close the switch that's connected to this PS on, which is this green wire right here, then it's going to give a low signal, a 0, to the processor inside the power supply, turn on the power supply. Now, you actually have access to this VSB, that 5 volt VSB. For those of you who have opened up a computer, more than likely, if you're watching this, you've probably opened up looked in the inside of a computer, at least taken a peek, right? And you may have noticed on the motherboard, there was probably a little LED that was on. Guess what? That LED that was on was actually coming, or it was being powered by this 5 volt standby, the standby voltage. And that voltage is actually connected to the motherboard to do all sorts of things, to power circuits like the circuit that's going to turn on the machine when somebody presses the button. So in general, that is just kind of this little voltage that's available for things that need to be performed when the system is turned off, right? Now, that 5 volt standby voltage, as we said before, needs to be connected so that this power supply on button can be used. So what we want to do is we want to connect a switch between this green wire, this power supply on wire, and any of the grounds that are nearby. You can just, and this is pin 14, so we have 11, 12, 13, 14. You could just simply connect this switch so that it was going between the PS on connection and a ground. And so on this guy, all I did was simply clip off the PS on wire, the green wire, simply clipped it off of this connector, connected it to this terminal strip right here, connected it to one side of the switch, and then connected the other side of the switch to the ground connection, so that all I had to do was switch back and forth, and you had a power supply on-off switch. All right. Now, next, you know, this power supply right here has a fan. And so when you turn it on, you can kind of hear the fan. It's actually pretty quiet, so you don't hear it really easily, especially if there's any noise in your work area. And you also might have, like this little power supply, this just simply has a heat sink and doesn't actually have a fan that's attached to it. So when you turn it on, how do you know it's on? That's when you are looking at pin 8. This power OK. This is going to be a 5-volt signal that comes out whenever the power supply is turned on. And that wire, let's see if I can figure out, I think it's I don't know, I think it's a gray wire that's coming from the power supply on. And whenever the power supply comes on, it will put 5 volts on here, and then if you connect an LED between the power OK signal, which is going to be 5 volts, and through a resistor to this ground, then you'll be able to have an LED turn on whenever the system is turned on. So what you can see, and you probably can't see it from where you are, but I have an LED, and then I have soldered to it a small 220 ohm resistor, and it's simply connecting between this pin and this pin. And so your circuit is going to look a little like this. Out of this is going to be an LED. So I'll just put a symbol for an LED, and then it goes through a resistor, and I drew my LED backwards, but you can hopefully get the idea. A 220 ohm resistor, and then whenever you turn on the power OK, and yes, I did draw that LED backwards, the current is going to flow. It's going to be controlled by that resistor, but it's going to allow enough current to flow through that LEDs to turn it on whenever the system is turned on. All right, so now we have an indicator to say that it is turned on. Now, you may have noticed when I held this thing up higher that I have something attached to this power supply. I have an old floppy disk. Why would I have an old floppy disk attached? Well, some power supplies, this one included, whenever it turns on, if it doesn't detect that there's something out there to drive it, to run it, or to run from the power, it's not going to turn on. It's going to figure it's not connected to a motherboard, so it's not going to power up. So if you think that something is wrong with your power supply, maybe there's nothing wrong with your power supply. Maybe it's that the power supply doesn't think that there's anything connected to it. So I have plugged in this floppy disk so that when this turns on, the floppy disk acts as a current draw from this power supply in order to tell it that it's got something connected to it, so that it knows that it can turn on. Well, that floppy disk is a little cumbersome, so there are actually easier ways to do that. This right here is a 10-watt resistor. This 10-watt resistor has a resistance of 10 ohms. So that means that if I connect this resistor to or between any 5-volt pin and ground, what it's going to do is it's going to allow current to flow. So 5 volts divided by 10 ohms, it's going to let half an amp flow. This guy could get warm, but it's a 10-watt resistor, so it's capable of handling large amounts of current. So all you need to do is really take one of these 10 ohm resistors, connect it between 5 volts and ground, and make sure you have a high wattage resistor, and that'll make it so that the system, the power supply, thinks it has a load. Now, we know how to do it. There's a couple of ways to do this. One of the ways that I showed you was to go ahead and attach our components to this power supply in order to make it so that the power supply will function with an on-off switch, a power indicator, and then a load in order to make it think that it's got something to drive. But there are other options that we have. For example, you could, on the web, just purchase one of these little breakout boards. Now, this little breakout board has actually got a couple of things that I'm happy about. For example, it has fuses here so that if any of the voltages, so we have access to 3 volts, 5 volts, 12 volts, and minus 12 volts, pretty much what I was saying before, right? If any one of these gets connected so that there's too much current flowing, one of these fuses will blow. Now, I'm not necessarily happy with the quality of this. For example, it came to me without any standoffs, anything to keep it from just resting on a ground and possibly shorting any of these contacts. But it does also have something that we can insert what we call banana clips into. And it's just simply a thicker wire with a really wide pin at the end that inserts into here so that you can have that wire clipped to any of the devices that you want to power. But you can also just simply unscrew this, put the wire that you want to connect, wrap it around this terminal, screw it back down, and it'll hold that wire fast. All right, this also comes with the on-off switch. In fact, it's even labeled on-off, and it has an LED to show that power is going. But one thing that we're missing from this is it doesn't have a load resistor. So if you have one of the power supplies that is looking for a load whenever it's plugged in, before it'll turn on, you need to add a load resistor between the 5-volt and ground connector. So simply just putting it on those terminals, screwing it down, will go ahead and turn on that power supply. Now, as I said before, what I've got for this little power supply here is just the 20-pin ATX connector. And so all I have to do is just simply know that this is pin 1 and this is pin 1 on this connector, line them up, it will plug in just fine, power directly from the power supply, and leave those 4 pins disconnected or just floating. But remember, those 4 pins just provide voltages that are already provided on the version 1 form of the ATX power supply. So there you go. A couple of ways that we can get power to our devices if, for example, we're using an Arduino or a Raspberry Pi that's not capable of driving the circuitry we want to connect to them.